Section 1.2, the law of the mean, also called the mean value theorem. We're going to do yet another example, a problem that says f is continuous on the closed interval from 0 to a and is differentiable on the open interval from 0 to a. In other words, it satisfies the requirements of the law of the mean. And f is 0 at the origin, so that comes out pretty convenient. And one more condition, f prime is an increasing function. What we're trying to show is that f divided by x, this particular equation, is also an increasing function. Now, if you think about it, as x increases, it's getting bigger and bigger, so f has to divide by a bigger and bigger number. So even then, we're trying to prove that despite this, the quotient is still going to be an increasing function. Now, to show it, we will use the law of the mean. We'll pick any x between 0 and a, which is in the domain, and apply the law of the mean, which says f of x minus f of 0 divided by x minus 0 is going to be equal to f prime of psi, where psi is just anything that's between 0 and x. Now, clean this thing up, we have, since f of 0 is given as 0, we simply have f or x divided by x equal to f of psi. And remember, the psi is going to be between 0 and x. And notice this is true for any x between 0 and a, okay? You pick any x, then fx over x equal to f of some kind of size, as long as psi is between 0 and x. That's step 1. Now, this next step we're going to do is define a different function. Let g of x equal to this thing that we're going to work on, fx divided by x. So then g of x is, we will consider the g prime, the derivative. And we will attempt to prove that g prime is a positive value always. If g prime is positive, then the g, that is this thing right here, is definitely increasing. Because anything with a positive derivative has a positive slope, so it's definitely increasing, and that's what we will drive at. So first we'll calculate the value of g prime by the quotient rule, which is x squared, and then f prime of x minus f of x. Okay, and the standard apply the quotient rule, we get this, and notice that because the denominator has a square in it, and we're concerned with this thing being positive, all we have to consider is the numerator, which is quite nice. So then we will consider this thing right here. Suppose we'll prove by contradiction, okay? We're trying to prove that g prime of x is positive, so we'll suppose it isn't. Suppose g prime of x0 is less than or equal to 0. x0 is just anything that is inside where x0 is anything in the domain between 0 and a. So if that is the case, what do we have then? Then we have this thing is, so then substituting in here, we will know that x0, f prime of x0 minus f of x0, this thing is going to be less than or equal to 0. Put it another way, in other words, f prime of x0 is going to be less than or equal to f of x0 over x0. Okay, rewriting it. Now, what is this? This is by what we just did. We know that this value, which is that, okay, is equal to some kind of a thing equal to f of psi 0. As long as there's some psi 0 between 0 and x0, such that this relationship holds. Now, however, since f is increasing, but f prime is increasing, okay, that means, so then f prime of psi 0 has to be less than f prime of x0. And yet we have just said that this is less than or equal to that. Okay, So then we have arrived at a contradiction. That's what I draw this as a contradiction, not a standard symbol here. So then we have arrived that this is not a possibility, okay? Because this thing has to be strictly bigger than that because the x0 is bigger than psi. And therefore, upon arriving at the contradiction, that means that this is not possible. Therefore, g prime of x is going to be bigger than 0 for every x in our domain, which means that therefore this thing right here, what g is, therefore fx over x is an increasing function. And that concludes our proof.